So in this video, we're going to explore just a couple more tangent theorems, starting with this first one, which is saying that tangents to a circle from an external point are equal. Now we're given some information here that O is the center of the circle. Our tangents are PT and AT, and we want to prove that PT equals to AT. So we can extend this dotted line from O to T. And what we notice is we've broken this up into two triangles. Now, with these two triangles, we are going to introduce them first, and we're going to try to prove they're congruent like we've done before, and then make a statement about the corresponding sides in congruent triangles being equal. So first, we're going to introduce our triangles. So in triangle TPO and TAO, we know that OPT equals to OAT. Now, the reason we know this is from the theorem we talked about in the previous video, which is that the tangent meets a radius at 90 degrees. You can say tangents meet radius at 90 degrees. And since they're both tangents, they both must be 90 degrees, so they're equal. We can also say that OP equals OA. And we know this because they have equal radii. We also know that OT is common. Now, with that, we have our three bits of information. So we can say, therefore, TPO is congruent to triangle TAO. And it's RHS because we have a right angle, we have a hypotenuse, and we have a side. So because we know these are congruent, therefore, we can say that PT equals to AT because the corresponding sides in congruent triangles are equal. Okay, now with this in mind, we've proved the theorem, so we are going to apply it to this question. So we're trying to find x here, and we know that the length of PT, or the length of x, is going to be 15 centimeters. And the reason is we are going to put the theorem that we just proved. So tangents from an external are equal. Okay, on to our last angle theorem. We are trying to prove that the angle between a tangent and a chord equals the angle at the circumference in the alternate segment. Okay, so we're given here that O is the center, NTR, angle NTR equals X, MN is a tangent to the circle, PT is the diameter of the circle, and we want to prove that angle NTR equals to angle RST. So we're trying to prove that this angle here is going to be X. Now, we're going to do this in a similar way as we've done before. We just want to use some of these circle theorems to somehow get that this angle is the same as the other one that I've just drawn in. We want to prove angle NTR equals to angle RST. Now, I've just joined up here. You can see the dotted line, P to R. There's a reason we've done this. Some of you may have already picked up on it, but we know that angle first, NTO, we know that angle NTO equals 90 degrees. We know that because the angle between a radius and tangent is 90 degrees. Angle between and tangent is 90 degrees. Okay, and we're told that angle NTR equals X, that's given. So we can say that angle PTR, so this angle in here, angle PTR, we know that because our angle NTO is 90 degrees, that these are complementary angles. So angle PTR equals to 90 minus X degrees. And our reason is complementary angles. Okay, now with this in mind, we're just going to leave this here. We're going to label this one as 90 minus x. Okay, now we're going to consider this triangle PRT. So this one that we have at the top. So with PRT, we're going to introduce it first in triangle PRT. We know that angle PRT, this one up here, is 90 degrees because of a theorem we've proved before. The angle in a semicircle is a right angle. So let me write that in. So PRT equals 90 degrees. And we know this because the angle in a semicircle is a right angle. Okay, and remember, with the angle sum of a triangle, okay, this has to be 180 degrees. So if we consider these angles, because I'm just trying to find this missing angle in here, I know that the angle sum of a triangle is 180 degrees. So if we add all of these together, then we basically are going to find that angle TPR is equal to x. We have the angle sum of a triangle. If you're not sure why that is, think of the angle sum of a triangle. We have 90 minus x plus 90 plus something else has to equal to 180. Now 90 plus 90 gives us 180 minus x. So we already have 180, but we're taking away x. So we have to add an x so that these cancel out, making the equation true, right? So we need this angle here to be x in order for the angle sum of the triangle to add up to 180. Now, with that in mind, we can make one claim, because we notice here that this angle, TPR, is x. This arc here, we can see that this angle that we're trying to find, RST, also sits on that same arc. So we can use another circle theorem from earlier. So we can therefore say, we can say TPR equals to angle TSR. The reason is angles in the same segment are equal. You can also write standing on the, or subtended by that same arc, or standing on the same arc. Or you can write it like this, are equal. Now, since those two are equal, we also know that that equals to our angle NTR at the start. But I'm just going to say, therefore, TSR equals x degrees. And finally, therefore, NTR equals to TSR, or RST. Oh, sorry, no. Equals to RST. That's what we're trying to find here. Sorry, yeah, TSR or RST. Either way, it works out. So let's just make it consistent with the previous one. TSR. Okay, and now we have proven this here. Now, we're going to apply this. So we're told that MTN is a tangent at T, and we want to find the size of RTN. So RTN, this one here, angle RTN is equal to 93 degrees. And our reason is the angle between tangent and chord equals the angle at the circumference in the alternate segment. So like with everything we've been doing so far, once we prove the theorem, we just use the theorem to find the unknown angles. So that brings us to the end of our remaining tangent theorems, our angles in circles theorems. Thank you so much for watching, and I'll see you in the next one.